What is going on, YouTube family? Today we're taking a play out of my good friend Guy Seguin's playbook, and that's welding around shapes. But today we do it with the Dual Shield Flux Core process. Shout out again to my good friend Guy up there in Canada. He teaches this lesson in his classrooms up there, and he's one hell of a guy. Basically, the premise is you just take some random shapes and put them on some plate or whatever you want to weld them to, and you practice working your hand around it, because we have to maintain a lot of variables like arc length, travel speed, torch angle, work angle, travel angle, things like that. And this is a good practice. Now this looks like a lot of material right here. I've got 3/8 plate, a big old hunk of I-beam that's probably a little bit thicker right here on the flange piece here than 3/8. And then we've got some 4-inch square tubing and some 4-inch pipe. This is going to be some good thick structural stuff for the process that we're going to cover today, which is Dual Shield Flux Core. And when you're welding around shapes and Dual Shield Flux Core, there are a few things to think about. When it comes to your personal protective equipment, I need something a little bit thicker. The normal gloves that I normally go to with those Cayman 1600s are a little bit too thin, and I'm gonna need something more thick to keep this hot process off my hands. Not only that, but I'm likely gonna have my hands in a kind of a fire zone as I work around these pieces of material. So I'm probably gonna opt for a thicker shirt. So I'm going to put the thinner FR away, and I'm going to grab this one from Up in Smoke that's got a lot of these Kevlar sleeves. So the combination of the thicker gloves, the thicker shirt is going to be the deal. Now when it comes to a welding hood, you got to have a good welding hood when it comes to Dual Shield Flux Core. Now I'm not saying necessarily you have to have the top of the line ones, those $300-400 ones. You can get a nice one like this Walter one here, this Spy hood. The big thing is we get our settings right. We want to go in there and get our shade, bump it up to probably closer to 12. We might want to even set our sensitivity a little bit higher because we're working around these corners, and we can set our delay a little bit higher. That delay is that screen going back to light after you're done welding. Again, this being a hotter process, it's going to stay brighter longer. So pretty much everything gets up. When you go, material thickness gets up, your voltage gets up, your glove thickness gets up, your shirt thickness gets up, shade, your sensitivity, your delay, everything goes up. Now we can get the material prepped and the machine set for this dual shield process. Again, just to reiterate, the material we're welding on it's pretty freaking thick. Oh, not only that, but it has a ton of mill scale on it. We want to have good clean welds, and we want to make sure that we're able to wrap everything around. So we did prep the material first. The I-beam, the square tubing, the piece of pipe, the plate. We went and grabbed our Walter grinder, just the 4.5 inches, all we needed, and threw on the flap disc as well from Walter. And that thing chewed through the mill scale, no problem. We don't have to do anything as far as putting bevels. We just want to get that mill scale off. Not only do you want clean metal, but you want a nice ergonomic torch for this. Abacore Benzol is known for their MIG guns, and they make a good lightweight ergonomic MIG gun, as well as it having the ability to interchange these necks and stuff. And this is something that I've seen in the field when you get into parts like this, especially whenever you're starting to practice your dry runs and you notice that there's some tighter spots to get into. You're going to want a nice lightweight ergonomic gun that has a flexible neck, or maybe just something to change out for whatever task that you're doing. Now we're going to keep things pretty simple over here. When it comes to this FCAW Rebel 285 IC, it has all the voltage we need to run Dual Shield Flux Core. We're running 75-25 mixed gas. You can run other blends as well, but we're going to be running somewhere around 26 volts for the flat position, and we might get somewhere higher into the wire feed speeds like 420, but that's going to be the flat. We're going to come over here and practice these simpler shapes in the flat position, and then we might have to opt to turn down the machine because we're going to take that I-beam and move it into, I guess you want to call it a 5G or a horizontal position to practice some other things. Again, I think this is a really good example of something to practice on. It may not look like but a couple welds to make, but there is so much metal you could put down on this, and you could essentially just have your students going one after another, practicing, working around these things, because it's, at the end of the day, it's all you can weld. So no matter what level experience you are as far as a welder, you should always be practicing those dry runs, those practice runs. But practice them as if you were actually welding. That's the advice that I'll give to you, because if you're not practicing like if you were you're actually doing it, then what's the point? If you don't have your hood on, you don't have your gloves on, it could feel or do something different than you thought. So get completely suited up and then start those dry runs. And if this is your part, you've got 3 things. And I purposely put these things together so tight so that there is some difficulty to it, because it's not always easy. Let us know the tightest spot that you have ever had to stick a MIG gun down in the comments. I've had to stick some MIG guns on broomsticks to reach them into some places. The idea is every part can be kind of quartered out. That means each individual section of this, like this would be 1, 2, 3, four quarters to every part. Easier to see on this here square tubing, and even this still has 4 sides more or less to it that we got to kind of consider. Now the reason why I say 4 sides, because if you're thinking like a fabricator, if you weld something on one side, it could potentially pull. Distortion is a big thing, so you kind of want to have that practice and mentality that you're not just going to weld it all out, weld it however you want. You want to try to keep things square, level, and plumb if they have to be. In this instance, we're not going to get too in depth with that. We're just going to try to put as much bead in one pass as possible. Now what I mean by that is, as we get down and we practice, we don't want to just weld out one of those quarters. I challenge you to at least get a third of what you're welding on a piece of pipe. At least break it down into thirds in something this size. If it's a little bit bigger, we'll see. The main takeaway that we want to accomplish today is set yourself up for where you want to finish, not where you're going. And you might have heard me say this before. If I want to start here and finish halfway on the other side, I want to get nice and comfortable where I'm going to finish and figure out what I got to do to reach to this side and practice that dry run to get to this side. To do this, I still have to maintain a certain gun angle. So you got to also think about it in that sense. Okay, what if I keep going? Can I make it all the way around in one pass? That's why you got to try those dry runs. So let's practice our dry runs and then let's weld. We got our dry run. I'm going to start here, finish here, get half of it done. We want to be able to see what I need to do, where my head needs to stay in order to do that. Might end up having to be here, looking around. Ultimately, I need my face to finish here, but I need my hand to catch here. Let's try it out. Try to maintain a drag angle. Try to stay super steady. The hardest part is likely keeping that bead the same size and in the same place, because your head's moving, you're not seeing the same part of the weld the whole time, and that can get tricky. You might be getting further away, you might be getting closer, but you can't really tell because of where your head's at. You don't want to start in one spot and finish to one side, unless you do. What I mean by that is, if you finish on one side, it should pull. It should always pull. But if you weld all the way around, it should always move back to the center. The last place I stopped was here, and it should have pulled this way. That's okay, because when I go to finish this weld and finish and stop right here, it should pull back. Now, how do I weld this? Like that. I gotta finish there. Well, you just get in where you fit in. If you gotta get somewhere to make it easier, as long as you're not breaking any rules, so be it. Now we want to try to not have to stop, but if we know we're going to make a boo-boo or we're not comfortable anymore, like I couldn't go that whole bead and not push that whole thing. So in order to maintain the same angle, well shoot, I got to stop, come around. It looks like I got to finish over here. That's why practicing your tie-ins is so important. And I already can tell you why I wasn't able to make it all the way over here, because I didn't follow my golden rule. Plan for where you want to stop, not for where you started. And the nice thing about this project is, yeah, we just made it all the way around, but that doesn't make this thing done with yet. You get to keep welding. We're going to go ahead and put a 2-bead on all this stuff today. If you're an instructor and you wanted more people to weld, put a 3 on it. Just keep welding. Pro tip, we know we got tie-ins here, here, and here. I want to try to avoid having a whole lot of tie-ins. I also don't want to put them all in one place, so I don't want to start here again. I can just, however, just start a little bit over here, and that counts as not making that tie-in in the same spot. I crossed the tie-in, but I can't make it. I can't make it. So we know that's a trouble spot. This I-beam's in my way. If it ends up being the way you weld it, that's the case, but there's usually a workaround somewhere. Not looking too great, honestly, as far as uniformity across the bottom, but it's been a while since I've wrapped around stuff like this. Bring her all the way around. It's kind of nice being able to look down over top of this pipe, because you can kind of get an angle on everything, but it's not always that easy. That pipe could be very long and you won't have that luxury. Body positioning, maintain gun angle. I'm all over the place, man. I'm all over the freaking place. The process of dual shield is really nice because it can lay down a smooth weld, and it's not like when you move a lot, it leaves a big ripple or nothing, but when you do move, you can definitely tell. Is it good? Sure. Is it pretty? Nah. Now you remember how I told you can't really go from here to here without, you know, pulling something? Ha, you can, as long as there's enough weld already there that's going to keep things from pulling. So being that I can't make it all the way around in one try, I could probably do it if I come from top to bottom. I drop my hand a little bit, rotate that wrist. Oh no, my arm's caught. My arm's caught in between the I-beam and the square tubing. I think I can make it. Planning on for wherever you want to finish, that's the biggest thing. As far as being able to make it in one go, you know, the more you practice, the better you get. Things tend to change a little bit when you work on square tubing. Now there's corners. You know the golden rule, you always wrap our corners. Now while the principle's still there, we still want to plan for where we want to finish and not for where we started, but now we've got these corners. The reason why you want to always wrap your corners is because those become stress points. A point or a part where something meets, like a tie-in, it always tends to be what they call a stress riser. So we always want to not put all of our tie-ins on top of a stress riser, because that's the first reaction. All we want to do is make a weld to here and stop. Make a weld to here and stop. We're going to do it just like that piece of pipe and no different, and wrap these corners. We're going to stop on these flat spots right here, right in the center, and we're going to wrap all the way around both corners and then finish over here. And pivot. Roll that wrist. And this is where we get that funky chicken wing, bending that hand backwards. Probably gonna have to move into a little bit of a push, but it'll be okay. I don't want to make it to the other end of that corner, even though I know I can, because I want to be able to wrap it. Oi, oi. Oh, that I-beam's tricky. I already don't like that. I'm gonna have to just wrap a little bit of that corner there. There's no right way to hold a gun. There's only a wrong way to put down a weld. I'm glad I put that I-beam right there. That's really testing me. We could see we were wrapping those corners, and then we're making our tie-ins on the flat side. See, this is where we're having the problems. See that? All kinds of nasty. You know that you have a problem area. Start there and work towards being comfortable instead of saving it for the last and just leaving it on top. Let's put the 2-pass on there. Probably a good idea to tackle it like we did the piece of pipe. Start up here and then work around. For someone like myself who doesn't do this on the regular like I used to, definitely puts things into perspective of where you sit on a skill level, because this isn't that easy. Can't make it. Got caught up. Finish up that pass. We'll put that final bead on it. Ah, stopped right on the corner. Oh my goodness. We're gonna third this one out. Just like I said, usually I find it the most easiest to third it out. I know that sounds weird when you got 4 sides to something. It's usually the way I can make it round. She ain't pretty, but she made it. So getting around that round plate and getting around some of that square pipe, you just gotta plan ahead. Plan ahead and wrap your corners. After it's all said and done, in a lot of cases, you're not perfect and still usually have the option in a lot of companies to take some sort of flap disc or so and blend up those tie-ins and blend up any of those inconsistencies you may have with your bead profile or your toes, and of course taking a wire wheel to get any of those pieces of BBs or anything else that needs to be blended in. You might be asking now, why the I-beam is on there still, Austin? Well, that's because we're going to take what we did here and put it into this. With I-beam, we've got to be a little bit more methodical about it because there are more turns, there's tighter turns, there's longer seams, there's places where you can't really get a grinder in there to blend anything. So we got to plan ahead. Now the I-beam again adds a degree of difficulty. We may not be running quite that 26 volts. We may go bump it down a volt and bump down that wire feed a little bit more in order to deal with the overhead and the vertical positions. But the biggest thing is we have a wrap around here, here, and of course again on those other sides. Planning ahead is going to be essential, knowing that that's going to get in my way. Can I wrap it around? Can I weld this flat? Can I turn that nozzle, maintain the gun angle all the way up into the overhead and all the way to the top? We're going to find out. I think it's a really good practice piece. Anyone that gets a hold of this is going to get value out of it as far as getting some practice in. Let's see how it goes. We're going to start at the center of that flange there on that I-beam. I feel my gun getting hit. We're going to try to squeeze through. Pop around, move quick, move quick, move quick. Probably got a little heavy on there, but it's alright. We'll be able to knock it down with a grinder. We just don't want to make too many mistakes inside this web. Can't get a regular grinder in there too good. We'll go up. I have to try to move my hand. Ooh, that was tricky. Rotate my wrist, try to find a way out of it. Go to that overhead spot. Tricky. Oh, we got the overhead angle. This honestly is probably the easiest one. And now I can finish strong, rolling around this last turn. Wide open spaces across the top and into the flat weld. That right there is welder's yoga. Not bad, not bad. Could get better, but that's what this whole thing is all about, is about getting better. Yeah, that vertical doesn't look the best. That overhead looks pretty alright. My wraparounds are a little heavy. You gotta have the bead size the same all the way around, and every time you get somewhere heavy like that, it's a different size. So you've got to go about fixing it, whether that's with a little bit of a grinder or you got to make some weld. But we were still able to get from bottom to top. We'll do this other side real quick. A little bit easier to get that gun out of this angle here just because it was already ready. I let my finger off the trigger there. It's going to be harder coming into here because we got a mad push angle. But I think this might be my more dominant side, because coming up into this vertical, I can already tell you this is going to be a little bit easier for me to maintain. Now you even have the ability to put a little bit of motion into it this time. An I-beam, while they may not all be welded just like this, it's definitely a funky looking shape and a good type of weld to practice on just because of all the grooves. Like watch, we're about to have to do a full 180 right here. I'm going to have to break away. Oh, put a hole in the plate just about. Yikes. We'll grind that out. It'll buff. Better bead profile. The vertical went a lot better inside there. That wrap did pretty good. That one was nasty. So that's something that would need to get ground out and fixed. But the rest of the weld looks pretty good. Now before I go and try to put any kind of 2-bead pass on this one, I got to knock down those high spots. We got to clean up any high spots or any inconsistencies in the weld size right now, because if we don't, then if we put more weld on top of it, the welds are just going to get worse and worse. If you want a nice smooth flat weld, you got to weld over something nice, smooth and flat. That little bit of grinding is going to be the difference in making those sides look decent or not. And even this high spot on the top, if I want that top to look the same, that high spot's got to go. Flat top it. Now we just rinse and repeat. Yikes, that one turn was no good. Had to turn that machine down. Woo, woo, woo. Just practice, right? Just practice. Not like the entire YouTube community is watching. And that's what can happen when you have a bit too much wire feed to your voltage. We just punched a hole into the plate, dig it out, fill it back in. That sucker's deep though. Doesn't go all the way through. But we turned down our wire feed speed there. Golly. Well, let's not do that again. I don't like this bottom one bit. Ooh, I need some better practice, man. Now we just gotta clean it up. I'm pretty much always gonna grind these sides because I suck at hitting them. Got some good stuff and some bad stuff, and if there's one thing that this has taught me is I need some practice. But again, guys, this is a pretty good exercise if you ask me, because there's a lot of welding we could do. I could sit here and weld on this thing for days, just working around it. If I've known anything in my experience, the fact that I'm a little rusty is just that. I'm rusty. I haven't done this in a while. And if you don't use it, you lose it, guys. So make sure you're always practicing. Make sure you always plan for where you're going and not for where you've been. And you wrap those corners. See you guys on the next weld. Let's try it out. Nice. You gotta have that ground on, guys. Every single time. My knees. Ah, I couldn't make it. I'll get you, my pretty. And your little dog, too. Bask in its holiness. I had grind mode on, I can't see anything.